All right, so question 2. I think the most important thing is creating a table. So once you create a table and the information is set up properly, the rest shouldn't be a problem. So again, don't forget the distance equals rate times time. So we got R, T, and D over here. We got 2 automobiles, 276. They're traveling different rates by 5 miles per hour. So if they meet after 6 hours, find the rate of each. So I know my 6 times 6 hours. Differing by 5 miles an hour. So if one is R, the other one would be R minus 5, right? And if I call this the faster one, the other one's slower, obviously, by 5 miles. So this is 6R. This is going to be 6R minus 30. And I know the distance, and again, the distance that they cover will equal to 276. So we can write the 6R plus 6R minus 30 equals 276. 12R minus 30 equals 276. Let's add 30 to both sides. You get 12R equals 306. And if you divide both sides by 12, I have no idea, but 306 divided by 12. Hang on a second. Pause. So we are at 306 divided by 12. We get 2.5. So that tells me that the rate, the speed of one guy is 2.5 over here. So the other one's 2.5 minus 5, which makes no sense. Sorry, I think I did it wrong. 306 divided by 12 equals 25.5. I'm sorry. 25.5. So that's the speed of the faster guy and this slower guy. So if this is 25.5, the slower guy is 25.5 minus 5, which makes him 20.55. Speed is 5 miles slower. Okay, so that's 2, 4. Again, this one seems like the same problem. Let's start with our table. A went at the rate of 20 miles. What was if they meet in 5 hours? Okay. So R, T, and D, they're 150 miles apart. A, call this A. A travels at 20 miles an hour at T. The other one, we don't know his rate. Hang on a second. It's not the one I wanted to erase. This is what I want to erase. So here's the distance. 5 hours. This is 5 hours. I'm gonna be missing that. Okay, so this is R. Okay, now I can do. So 20 times 5. The distance covered by this guy would be 100 miles. And this guy covered 5R. And I know that these two distances, they're 150 miles apart. White paper?
Can I go to the bathroom?
There's a girl out. When she's back.
Okay.
So we get 100 plus 5R equals 150. 5R is equal to 50. And R equals to 25. So this guy is traveling at 25 miles an hour. Six. Again, same situation. I have more room over here. RTD, let's see what I have. Yep, so one, again, I'm going to call this slow, and this one call it faster. This travels at 25, this travels 35. After how many hours were they 100 miles apart? Oh my god, so this one's a little different. Right? Do I know the time? No. I know the time, and the distance here is 25t, and this is 35t. But the question is, after how many hours were they 100 miles apart? Well, hang on. So with this one, my understanding was a little bit different. So here are two cars, car A, car B. Car A is going this way, car B is going this way. After a certain point, car B is going to be here, a certain time car B is going to be here, and car A is going to be somewhere over here, right? When is this distance going to be 180 miles? So that's the question. They're going away from each other. So again, this is 25t plus 35t equals 180. That gives you 60t equals 180. And in 3 hours, they're going to be 180 miles apart from each other. Question 10. A motorboat Alright, okay, so leaves the harbor and travels, so here's the harbor, and the boat travels that way at 50 miles. And then to an island, right? Let's call this an island. And then on the way back, travels at 10 miles an hour. How far was the island from the harbor if the total trip took 5 hours? Okay. Let's set up. Okay, so this is not it's the same question. You're going from the harbor, to an island, right? On the way, you're going at 50 miles. On the way back at 10. Okay, maybe you're going with the current and against the current. Okay, so if you do your table, let's go. There's two, and call this from, by the way. So going to the island, you're at 15 miles. The time, R, T, and D, the time that it took you, let's just write T. So the distance is 15T. From the island, you're traveling at 10 miles. And if the whole thing took 5 hours, well, obviously, be 5 minus T over here, and this would be 50 minus 10T. The distance to and from the island is the same. It's just different speed. So you got 15T equals 50 minus 10T. You get 25T equals 50, and T equals 2, right? Yeah, T equals 2. Now to find the distance, we can plug the 2 over here. So we got 15 times T, which is 2 in this case, and we get that, all right, 15 times 2. So we know that the distance from the harbor to the island is 30. Whether you substitute it here or here, you get the same answer. You still get 30 miles. Okay? That was 10. I'll pause while I read. So question 15 is the same thing as the one that gives you the head start, the one that we did that in class. So we have a motorboat, right, M, and then we have a cabin cruiser, R, T, and D. The motorboat is a slower one, 8. The cabin cruiser is a little faster, but the motorboat traveled at T, and he had how many hours head start? T plus 2. T plus 2, and this guy's only just T. Okay, so multiply this, you get 8T plus 16. This is 16T. We're going to write that the distance that they each travel is the same, right? So we're going to get 16 equals 8t, and t equals 16 divided by 2. In 2 hours, they were side by side. So 16 has the same idea here. It's a runner. One gives the other guy a head start. So I'm trying to do this at the bottom. So I'll call this slow runner, fast runner. Alright, T and D. Give me a second. Yeah. So the slow guy is 6 miles an hour. The fast guy runs at 8 miles an hour. But the slow guy had an hour head start, so it's t plus 1. The other one's just t. The distance that they cover, well, this is 6t by the way, plus 6. This is 8t. So the distance that they cover will be the same, right? 6t plus 6 equals 8t. So you're going to get 2t on this side equals 6, and t is going to be 3 hours. It's going to take 3 hours for the fast runner to overtake the first runner. Okay. '17 again is the same. So we got a car and a cyclist. Car is traveling at 48. The cyclist is traveling at 12. The cyclist had a 3-hour head start, right? So it's t plus 3. The car is just t. And we want to know how far from the starting point does the car overtake the guy. So 48t. This is going to be 12t plus 36. So first, let's find the time, right? So once we have the time, we can substitute and find the distance. So it's 48t, 12t plus 36. They're equal to each other because the car has to travel the same distance the cyclist traveled, right? So let me just get to this. Sorry. So you're going to get 36t minus 12t on each side. You get 36t equals 36. T equals 1. Basically, it took 1 hour. So, and how far from that? Well, if you substitute t with 1, you get 48 times 1, which is 48. In 48 miles, the car will overtake the cyclist. So whether you substitute it here or here, it doesn't really matter. And that's that.